My name is James Oakley, one of the founders of Vixen, and in this short film I want to show you the Vixen engine that over many years we have developed, and it's the only engine of its kind in the world capable of generating renewable electricity from a whole variety of waste fuels, low quality fuels or contaminated fuels that other engines simply can't run on, or in some cases, if they can, cause huge maintenance problems. So this is extremely unique. Our first engine is running on an old landfill site, generating electricity from gas that is normally flared off, and no other engine can generate power from this sort of gas. So this just goes to prove the concept and what we're about. The purpose of this short film, apart from showing you what we've got and a little bit about Vixen, is to raise money and to look for a serious investor to take the business forward. We now have very limited investment funds, which is stifling us for what we want to do, and we need to really get going. We would much rather have an investor who comes from a background that is suited to the engine, and we're bringing in complementary skills apart from just cash, so we could work together to build this business. I hope this short film ahead will show you some detail of the engine, and I'll summarise afterwards a little bit more for you. So here you go.
Here is the Vixen engine in its purpose-designed container on a landfill site, generating electricity from low-quality landfill gas that is normally flared or vented, and that no other engine can run on without the addition of a pilot fuel. Here you can see around the other side of the container the landfill gas that would normally go to a flare coming down through that black line into a knockout pot that takes out moisture and any slugs of water. Then up it goes into the container and into the engine gas compressors inside. At the end of the container on the ground you can see some black lines with the power cables in where the electricity is coming out, being fed into a transformer to turn it into high voltage and off into the national grid. Here we are back in the container again with the side panels removed for access and to enable this video to be shot. You can see the generator on the left hand side coupled to the high speed reduction gearbox in green there, and overhung from that is our turbine engine just sitting behind that white oil breather. There's the very large combustion chamber, and behind that are the gas compressors just tucked away, slightly out of view at the moment. The combustion chamber is very novel and a big part of this concept. Single can reverse flow 2-stage, enabling us to burn low quality landfill gas and other low quality fuels too. A huge amount of development work has gone into that over the years. The generator, the other end, is 1500 RPM asynchronous generator, which also acts as a starter to start the engine, driving into a coupling into a 2-stage epicyclic gearbox, which drops the engine speed from 70,000 RPM to 1500. At the back of the picture there, at the top in yellow, you can see the gas train where the landfill gas actually comes in and is then piped down to the gas compressors that were out of sight, compressed and then burnt in the combustion chamber. Here you can see a closer shot of the oil system. There's the gearbox sitting on top of an oil tank with an oil system surrounding it, the oil tank below the gearbox, and there's the engine just tucked away, overhanging from the gearbox behind the oil breather there. The whole system is bolted onto a skid there, so for ease of changing over that can be lifted in and out of the container as a complete item. Here you see the combustor gas inlet end with the igniter plug and propane pilot burner for starting up. Now we move to the other side of the gas compressors, where you can see the gas control valves that control the flow into the gas compressors and hence the engine speed. These are all PLC controlled from the control room at the other end of the container. You can see the cooling fan there for the oil system for the 2 gas compressors. Here we have a 2-stage centrifugal gas compressors, both turbine driven in series, where the gas comes in, is controlled, pressurized through the first stage up into the second stage, and then out to the combustor. And there at the top left of the picture you can see the propane control valve, which controls the flow of propane into the engine, which is only used for lighting up, and then once the engine's established, the propane is shut off, and the gas compressors that you can see in the centre of the picture there have enough work to provide total engine performance without any propane at all, and the engine's gradually wound up to speed. And the whole gas compressors are there contained on a self-contained skid, again accessed through a very wide door at the end of the container. You can see in the background there the recuperator, or the heat exchanger, which is quite heavily insulated with the exhaust going vertically up through the roof. Here is the engine control room at the opposite end of the container, where everything's run from. The engine's basically controlled by a Siemens Step 7 PLC. Here you see the display screen showing the engine layout diagrammatically with all the various temperatures, pressures and flows on it, so we can see what's going on. And on the laptop on the left we've got vibration monitoring equipment there and a readout. You see the ABB ACS asynchronous inverter in the far corner on the left there, and then in the near side here you see the engine control box with all the various engine controls in it. We're now down at the far end of the landfill site that's still open, where rubbish is still being tipped, and this end is obviously producing very rich methane gas that's being used by conventional spark ignition gas engines to drive their generator sets, whereas we're using very old gas, which, as you'll see in a minute, comes from the mature end of the site. Here we are now down at the original, or the old end of the site that was reinstated over 15 years ago now, mostly covered with planted trees, as you can see, and a nature reserve in places with a footpath over it. You'd never really know it was full of landfill, so this is where the low quality gas that our engine is running on is extracted from, and under normal circumstances this gas would either be flared off, or if it's very low quality, even vented. So here you can see a typical case of a big large landfill site where it gets old and still is producing gas many years later, that instead of just being wasted can be turned into electricity. So we now move to Rathhouse in Northern Ireland, which is at Lisburn, just outside of Belfast, and this is where Vixen has its factory and workshops. We have half of this building that you see here, so we have 5,000 square feet, and that incorporates our offices and design offices, as well as workshop and initial assembly floor space. We can now take a quick look at our design capability, where, as well as 3D CAD, we have FEA analysis of various engine components, including a turbine blade, and CFD that we also use quite extensively. So here, for example, is a cutaway of our combustion chamber, and then of course the link we have with Queen's University in Belfast. So, as previously explained, there are many other fuels and markets as well, and that includes renewable combined heat and power, where with the addition of an exhaust heat exchanger we can use the heat from the exhaust for heating buildings, hot water or industrial processes, reverse cycle air conditioning or desalination of water. There's all sorts of applications. Our speciality, however, is low quality fuels, or very difficult fuels, and ones that conventional engines either can't run on at all, or that really struggle to run on and cause them all sorts of problems. So, for example, we're presently looking into glycerin, which is a waste product or a byproduct of biodiesel production, and using that to generate power and heat. So to sum up then, there's huge potential for this new technology that we have now proven and shown is viable in renewable power generation, where we can use the financial incentives here in the UK to get the business started and then develop the business globally as we roll out the engines in a proven and production basis. So if you're interested in initially investing from £1 million to £3 million over the next 2 years and building the business with a potential exit in, say, 5 years to a leading engine manufacturer, which will give a substantial return on investment, then do please contact me. My email address is j.oakley, that's OAKLEY, at vixen, vykson.com, or my mobile number is 0044 7860 711 595. Thank you very much.